Hey guys, so we're gonna do Oceans, Atmospheres, and Climates, lesson 1.4. So we have 5 activities today, as you can see. We're gonna start with our warm up. So it's predicting air temperatures in different locations. You're gonna open the sorting tool and make predictions about cold and warm and hot places on Earth. So you're gonna move the green thermometer where you think it's cold, the yellow where you think it's warm, and the red where you think it's hot. And then we're going to move the labels to show the true about the energy and location. So let's hit this warm button. Where might you think there would be some cold temperature? I know for me, I know that Antarctica is cold, right? And that's at the bottom of the earth. And I also know that towards the top it's cold too. And it's warm. Right? In this middle area, it's warm around us sometimes, right? And where we think will be hot. Yeah, right, like in South America and in Africa, we would have hotter temperatures, right? That's where I know that in Africa, that's where our deserts are. That's where, we have a lot of tropical areas. And here in South America, too, we have a lot of tropical areas where it's warm. So we learned week before last that different temperatures tell us something about energy, right? We learned this a while ago in our heat unit that the more energy something has, the higher the temperature is. So low energy would probably be in these areas that I'm labeling green, and my mediums would be in these yellows, and my high temperatures will be right here along the middle. So now that I've done that, I'm going to hit hand in and make sure I hand in my work. So boom, my warm-up is now done. We're going to watch a video next that shines some light on our unit that we're learning about. And in this video, first thing that's going to happen is going to introduce 2 new vocabulary words, and those are equator and latitude. So I'm going to let this video play, and then we'll come back to me.
And then this is really important. You need another person to talk to. The reason for that is because lots of times when you're thinking of new ideas, having someone to discuss them with will help you develop your ideas even more. And then the last thing that you might need is a flashlight. Now, don't worry if you don't have a flashlight. Okay, so as we're getting started, there's a new vocabulary word that we need to learn, which is equator. And maybe it's one that you already know, but there's a picture here of the planet, and there's a red line here that says equator. Equator is just an imaginary line that divides Earth into a northern and a southern hemisphere. So as we're thinking about the planet, everything north of the equator is in the northern hemisphere and everything south is in the southern hemisphere. Okay, so the next vocabulary word is latitude. And latitude is just how far away you are from the equator. So you can't know this word unless you know the word equator. So the definition is the distance of a place north or south of Earth's equator. And if you look at this map here, you can see that there is a line down the middle of this map that's labeled as 0 degrees, and it's also labeled as equator. And then if you go to the next line, it says 20 degrees north. And if you go to the one beneath the equator, it says 20 degrees south. So the number there, the latitude line, just tells you how far away you are from the equator. If you're at 60 south, that just means that you're 60 lines below the equator. So we're going to take a look at a couple maps. And as we're thinking about these maps, I want you to think of 2 things. One, what is this map showing, and what patterns do you notice? This is where having someone to talk to is such a great idea. So I would love for you to pause this video if you're able to, and just quickly discuss with someone else what you think this map is showing, what patterns you notice. You can also write some notes in your notebook, just a couple of things that you're noticing about this map. It's very colorful. It's very complicated, it looks like. Okay, so if you've paused it, welcome back. Let's go ahead and talk about some of the things that we can notice about this map. One, there's this key at the bottom, and it tells us different numbers, and then it says degrees Celsius. So I can infer that this is telling me the temperature and that each color corresponds with the color on the map, and that's what temperature it is. And I noticed that along the equator, the colors here are oranges and reds, which correspond with the degrees Celsius that are hotter. And then down below, and also at the top, I see a lot of blue, which tells me that those temperatures are quite cold. And that is really cold. Look at that color there. It looks like it's negative 20 degrees. Ah, that's very cold. So Iceland, which is this little dot right there, that's one place that I thought was cold. And if I look at it, I can see, yeah, it's the average temperature there. Looks like it's between 0 and 5.2 degrees Celsius. And another place that I thought that was very warm is Hawaii, which you can see right there. It's a little chain of islands, and it's right there in that orange, which shows that the average temperature there is, you know, pretty warm compared to some other places. You can see it's right kind of in this dark orange, or right above the dark orange. Whereas where we live here in Seattle, it's more along this like lime green color or yellow. So there's a lot of things to notice here on this map, but let's look at this next map, because different kinds of maps can convey different kinds of information. And what do you notice about this map? You can pause the video and talk about it with your friend or someone at your house, or you can take a moment to take some notes. I'm going to sit and look at it and try to see what I think about it. One thing that I notice here is it doesn't have quite the same amount of color as the map that we were just looking at. And the lines are very horizontal. I'm noticing that as well. The key here says that the light orange that's right along the equator says most energy from the sun. And then the white line, which is here at the South Pole and the North Pole, show least energy from the sun. I notice the title says incoming energy from the sun. So I will infer that this map is telling me that the closer I am to the equator, the more energy that part of the Earth is getting from the sun. Why would that be? I'm going to show you another picture, and this picture might help us kind of understand why the incoming energy from the sun would be different at the equator. The thing to remember is that Earth is round. It's a globe. And the reason why that's important is that explains why it's warmer in Hawaii and colder in Iceland. So if you look at here, that this picture is showing on the very far left side of the screen, there is this sort of yellow line, and that represents the sun. Now the sun is 150 million kilometers away, and they're making it seem like it's really close, but it's not. Don't be fooled. It's very far away. And the energy that comes from the sun, when it arrives on Earth, it's all traveling horizontally. The sun is very huge and it's very far away, and all the light that's hitting the sun, coming from the sun to Earth, is just hitting the Earth straight on. At the equator, where the Earth is facing head on to where the sun is, the sun's rays come in, and if you look at this, you can see that we have to do a little bit of math here, but math is fun, so that's perfect. The lines are coming in here, and the angle that they are to the Earth's surface is a 90-degree angle. But if you look at the top portion of this graphic, it shows that these rays are coming in, and if you look at the angle there that they're hitting, it's a much lower angle. Here it looks like it's about 45 degrees for where it goes in, and then the angle there, do you see that? Versus this angle here, which is 90 degrees. And if you look at this, you can see that the smaller area at the equator is actually receiving the same amount of energy as this larger area here. The amount of energy that's coming from the sun is the same, but the distance across Earth's surface, the area that it covers, is actually quite a bit bigger. So you can actually use your flashlight for this to show how energy can change intensity by the angle that it comes in at. So if you have a flashlight, you can try this. You can turn it on, and when you turn it on, you can see that there is a circle of light that comes from the flashlight. So you might also have a flashlight on your phone, but it doesn't work quite as well. So if you have that kind of flashlight, what you're looking for is the kind of flashlight where you can get a circle like that. Okay, so let me show you the directions for this activity. It's fun to do science out of school. So I'm going to have my picture disappear for just a moment so that you can see the words on the page. So here are the directions. Start by pointing your flashlight straight down onto a table. It works better if you turn the lights off in the room that you're in, or if you do this activity at night so that you can see the circle of light from your flashlight. And then point the flashlight straight down and notice how intense the light is from that circle. And then take the flashlight and turn it at an angle as this picture is showing here. Now it's important to try to keep the same distance from the table. We don't want to change all the variables. We just want to change the angle. You don't have to use a ruler. You can just kind of like eyeball it, but I want you to try to get as close to the table as you were both times, so that's the same. And then the last part is just, what do you notice? And one of the things that I notice as I look at this is that the circle of light here is much more intense than when it comes at an angle, because that amount of energy has spread out over a larger distance. And that's what's happening here on our planet. The amount of energy that is coming in near the poles is less intense than the amount of energy that's coming in at the equator. So how does that affect the amount of energy that comes? Well, if we look at this picture one more time, we can see that because the energy comes in more intensely at the equator, locations on Earth near the equator actually get more energy from the sun than locations that are further away, because the energy from the sun is spread out over a greater distance. Now, if our planet was a cube shape, or was flat, then that wouldn't happen. But because our planet is a globe, that's why the equator is so much warmer than the poles. Okay, so let's go ahead and explore the sim for a little bit, just to kind of show how the energy might be different at different places. So if you have an account on Amplify, if you're a sixth grader in Seattle and you can get onto your account, then go ahead and do that. If you don't have access to Amplify either because you aren't with a computer or something like that, don't worry. I'm going to go ahead and explore it with you. So let's go ahead and go to Amplify, then you click on the global navigation menu and scroll down until you see Oceans, Atmosphere, and Climate, and click on that. Okay, I'm going to go ahead and do that. Okay, I opened the sim, and this is what we can see. I changed the temperature view from none to surface because I want to see a map that looks similar to the map that we were just looking at. And what I see here is that, yeah, that's very similar to what the other map that we were looking at. Along the equator, there are red and orange colors, which indicate that the temperature is greater. And near the poles, the temperatures are much colder. So let's go ahead and hit play, and I'm going to start moving some water around. And you can see that even as the water moves around, by the equator, it tends to be warmer. And even the water isn't really changing that a lot. So that's interesting. Okay, so we'll explore the sim a lot more in the next lesson, in lesson 4. But for now, I just wanted to point it out to you to see that you can see that our computer model that we're using during this unit is similar to how planet Earth works. So the question that we need to try to understand is, how are energy and temperature connected? And as I'm looking at this, I can see these two maps here. There's the incoming energy from the sun and the global air temperature. And I think that what we've discovered as we've been doing this lesson together is that we've discovered that the amount of energy that comes from the sun directly affects the global air temperature. Locations near the equator are warmer because they're receiving more energy from the sun. So the investigation question that we started with today is, why do different locations have different air temperatures?
Hey guys, so welcome back. So right now we're in part 2, and we looked at the information that we see in these 2 maps. And you might have turned and talked with somebody or jot down your ideas about what is the information that these maps show us, and how do these maps go together to provide evidence about our investigation question, which is, why do different locations have different air temperatures? So I'm just gonna hit next. You guys should have covered the word latitude, which is the distance between the north or south of the equator. And remember from the video that the equator is this line that divides the globe into northern and southern hemispheres, right? And so I'm going to hit next. And so based on what we saw and what was discussed earlier in the video, you should be able to answer the question, why do different locations have different air temperatures? And I want to make sure that in your response you're using the following words. We want to talk about energy, we want to talk about temperature, and we want to talk about latitude. So here's a hint. We know that as temperature increases, energy is also increasing. So we want to look at what do we see happening here, and how does that translate into temperature? And we want to talk about what's happening at the different latitudes. Okay, so once you fill that piece in, we're going to hit next. And our final piece for part 2 is to investigate air temperature in different locations. So we're revisiting our warm-up. So this is a completed map of my warm-up, right? And then you are able to revise your map. So let's say that I changed my mind about something. I can click this plus sign to add an annotation. So here I'm going to write my annotation, and I'm going to write, the higher the energy, the hotter or warmer the temperature. Right? If something gets more energy, then it's going to have a higher temperature. I'm going to put that over here. So you can add annotations, and your annotations can say anything. Maybe your annotation wants to say that I've changed my mind from earlier, or maybe your annotation is like, I think I did excellent, right? We're just going to make sure whatever it is we changed, however we changed it, we are going to hit update. Boom. So now your work has been updated, and we're all done with number 2. Let's move on to number 3, which is our modeling tool. So we are going to be modeling why different locations have different air temperatures. And we just learned that in our exploration that when we look at different air temperatures, right, they're getting different amounts of energy from the sun. Well, the distance traveled is less. So at the equator, we see that all of the energy is focused in one small area. Whereas if we look at, towards our poles, we see that it's getting that same amount of energy, but that energy is going to a much larger area. So there's less energy overall, right? We learned in our thermal energy unit, right, that the amount of energy, right, even though we're getting the same amount, the surface, how far it has to spread, takes account. So I'm going to model why 2 locations, the equator and the South Pole, have different temperatures. And I'm going to use energy transfer arrows to show how the energy from the sun is transferred. And I'm going to use thermometers to show the resulting air temperature. And we can model the air temperatures in both locations, use the blue temperature, add information, and properly connect it. So I'm going to click on my modeling tool here. Okay, and so we here our goal is to have two locations have different temperatures. We're going to use an energy transfer arrows to show how the energy from the sun is transferred to the air. And I'm going to select the size of arrow to show the amount of energy being transferred, and the thermometers to show the air temperatures. So now that we have a quick refresh, remember that we're going to use the blue pencil to do this. So energy is transferred. We know that energy is transferred from the sun, right? And we know that it's going all the way down to the land and water, right? It comes from land and water. And we know that energy is going to be transferred from the land and water to the air. And so I'm going to put my other arrow to show to the air. Boom. And we're going to look at temperature. So this is the equator. So the equator, I know that this is a direct connection. And so I know this temperature is going to be very high. And I'm going to put my temperature over here. And I'm going to make my temperature high. Right? And this is just a guess. Maybe you feel like your temperature should be different. And then we know that when we transfer energy, right, we lose a little bit of it. So I'm going to make that high. Because we know equilibrium has to be happening. So some's going to go to the water, some's going to go to the air. So there's that transfer of energy. So I'm going to say it's warm. Right? So it's just an idea. Yours does not have to look like this. And so now I'm going to draw from our South Pole. And we know that energy from the sun, right, is going to be what connects to, I wonder if I can do that. Yeah. No, this is moving at an angle. Nope, I can't do it. So, and we know that energy is being transferred from the land to the air and from water to the air. Right? And we know this temperature is going to be lower. So I'm going to put very low. And then my air temperature, let's put that's low as well. Right? Now, once again, this is just an idea. Your idea may be different. This is not necessarily right. Notice our equator is here, 0 degrees latitude, and our South Pole is all the way at the bottom. So once you finish that lovely model, you're going to make sure you hit hand in. It's going to say, thank you for handing your work. And you're going to click OK. You're going to close that tab. And then you should see it here. And then once again, if you want to add any annotations, right, if you want to describe it. So for example, I think that it would be cold in the South Pole because the energy from the sun has to travel further. Right? And this could just be whatever you want. So I'm going to put this by my South Pole. And then we're going to hit update. Something I wanted to go back to in number 2. So I'm ready to move on to my homework. I just wanted to cover this really quickly. In number 2, if you look at number 4, if you hit where it says warm up, it will take you back to the first warm up. So you'll be able to edit it if you wanted to move any of these temperatures. I just wanted to cover that because I don't think I did. Alright, so the only thing left for you to do, my lovelies, is your homework section. So you're gonna go to the simulation and you're gonna place sensors at 1 and 2, and you're going to record the energy level transferred from the sun. So you're gonna go low, medium, high, right? And then you're gonna record the air temperatures, and then you're gonna reset the activity and place a location sensor at 3 and record what's happening there, and you're gonna answer this question. So just looking at, remember that we want to go to current map mode and then select air for temperature view. So temperature view, we want to do air. Okay. And we wanted .1 and .2. Remember, later on you're going to put the third dot here where it said number 3. And we wanted to check the level of energy from the sun, whether it's low, middle, or high, and the air temperature. So let's look here. The energy from the sun, let's see. From looking here, I can see that it's this bright blue, and so the temperature is -10. So we know that that temperature is showing us that we have a low energy from the sun, right? We have low energy from the sun. And then, right, it's much smaller here, this arrow, where it says energy from the sun to surface, much smaller here than it is at point 2. So point 2, we might say, has medium or middle. And then, can anybody guess what point 3 is? Exactly, yeah, point 3, you were probably right, high. And then you're going to get the air temperature in Celsius. So, make sure that we're recording the energy transfer from the sun and air temperature. So, let's put it. Right, and remember, we let it play until these temperatures have reached equilibrium. Jackson's just going to make this go a little faster. And it looks like the air temperature is in between 1.3 and 1.4. It goes up a little, it goes back down. And then for here, it's at 24, stable. So I'm going to write my 1.3. I'm going to write my 24. And then I want you guys to tell me what you see here with 3. And remember, you're going to answer this question here. Okay? And once you're done, you're going to hit hand in. Now, number 5 is extra credit. So you can do this with your family if you want to. You're going to record your questions below. Tell me what your family learned after talking about it with you. And that is extra credit. Alright, guys. I shall see you again on Wednesday. Have a good day.